Yes, I'm going to start off with the assignment 2. So I have logged into Azure Machine Learning Studio Classic. So I will start by making a new blank experiment. So here you can see all the saved datasets and all the other transformations and machine learning models. You can even use other Python language models, and you can create a pipeline basically. So what I'm going to do is I'm going to first search up the automobile dataset by price dataset. I'm going to drag it down and I will move on to the next step, and I can visualize it. Here we can see the dataset as a data frame. We can see all the features. We can see the price, the IV mapping, everything. Yes, next we move on to the other step. Can go back to visualize. Can go to normalize losses, and we also can see statistics such as mean, median, standard deviation, and all the other values. And we can also see a histogram of frequency. Yes, we can move to the next step to select columns in data set. You can directly connect this to this. Yes, and now you can open up launch column selector, and we can go by rules, all columns, and we can type the column name normalize losses. Maybe we can use another one as length. So we can select these two, and now we can clean the missing data. We cannot visualize in this step, but we can clean the missing data. We can next connect this to this. And in cleaning mode, you can remove entire row when it's an empty column. So in the dataset, it will completely remove it. Yes, and next we can move on to the other step of again selecting columns from the clean dataset. You can see here, this is the clean dataset. This is another set. Yes. Next we can again select the columns, dataset, and connect the cleaned dataset to this. We can launch column selector now. And here we can select all the other columns such as make, wheelbase, engine size, horsepower, engine location, number of doors, and number of cylinders. Okay, next we can move on to the next step. Here we would split the data into training and testing. So before entering into the model, we can split it. Split the data. Okay, connect the dataset to this. And in splitting the dataset, you can say which fraction of rows. So it's normally recommended to have around 80 to 20 or 90 to 10%. So I would go with 80%. 80% for training and 20% for testing. Next we can come up with, next we can train the model, and we have to connect the on this. We can take this as the testing dataset, and we can connect the dataset to this. And for a machine learning model, we can take either linear regression, or can take a regression model such as Poisson regression or neural network regression, ordinal regression. Maybe we can take a decision forest regression, and we can connect it to when training the model. And again we can launch the column selector, and we can use price to be the predictor. Yes, that would be a predictor. The predicting attribute that will be predicted by a model. So then we can run a flow where it will train the dataset. So it's going to take some time. You can see one by one it gets ticked. So we split. The model has been trained. It's not found. Okay. Oh, I think we had to enter price here. Yes, we need price, so got to add the price here. It'll start running again. Yes, I think yes, we can take a small visualization of the model, as this is a decision forest tree that will be made. It's a bit slow, but it'll come up. Yeah, you can see the decision making done by the decision forest tree. It has come up with the tree, so it's very easy to visualize. This is a low-code platform, so it has very many useful tools. Next we can move on to scoring the model. And for scoring the model we can use the train model and the testing dataset. And again we can run it. We can run selected. I have no idea why it tends to rerun the whole thing. Yes, we can see the score, and I think we can visualize it. Or can we not? Yes, we can visualize it. Yes, we can so see the scores that has been given, like the scored label mean and the scored label standard deviation. For the price, this is the predicted price and the label mean. The price has been predicted here. Yes. Next we can move on to evaluating the model, and here also we can use the testing dataset to evaluate it. So we can use this code model directly into evaluation. We don't need to connect the testing dataset again because we scored the model already. So we can select this and we can run selected. Yes, we can see now that dataset is finished with the evaluation, and we can open up the visualization for it. So yeah, so you can see all the values, you can see all the metrics, you can see absolute mean value, root mean square, relative absolute error, coefficient of determination. So we can see all of that after all of the metrics for the model after it has performed the evaluation. So that is the end of part 1, and we can see the errors are quite low, but there is absolute mean error which is kind of high for this model. So this might not have been the best model to be selected. So maybe we could have gone with a linear regression, which would be more suitable for in this case. Yes, that's the end of part 1. Thank you. Hi, let's start with part 2 of the assignment 2. So first we can download this dataset from the UCI library. I've already done that, and you can see it in this folder. And now we have to convert this dataset from .data format into .csv. For that we can use this command. So CSV is easier to work with in Machine Learning Studio, as the backend is mostly Python based, and it is, especially with pandas, it's easier to work with. So next we can see this, we can see it's created. Next we can create a new dataset. We can upload from local file. We can choose the file. We can get the German.csv. We can name it as the same name they have given. It should be UCI. Should be with no headers. We can say German credit card risk details dataset. You can see it's uploading. Yes, it's successfully uploaded. Now we can move on to creating a new experiment. We can start with a blank experiment. We can search up UCI German credit card. Yes, this is my datasets. So they already have the sample one, but we're going to use our dataset, and we can visualize it. So we can see that it has picked up different columns, and since there is no headers in this dataset, yeah, yes, we can see that. We can provide a name for this as German credit card risk experiment. Also provide German credit card risk analysis and prediction. Yes, we can save it. Okay, there's no materials to save it with, so the next we can look into the what they have said. We can go to edit the metadata. Can you see it in metadata? data. Connecting directly to this, and in that one, yes, we can have new column names. Can go to column selector, can move everything here. Then we can copy this and add it to the new column names. And next, yes, selected columns, yes, that's done. So then we can split the data. Okay, and we can show action of 8.0, and do they suggest having a randomized split? They don't suggest anything. Yeah, and next we can use this and execute our script. We can add this our script in this, and see this correct. And we can add that it is set cost adjustment. Yeah, you can see the comment in that. And for the other one, we will use the same one, same script. So it's the same script. Cost adjustment. this just to run it. Let's start running it now. Hopefully it runs without any errors. Yes, that's part 1 done. We can move on to tutorial part 2. So now we can use a 2-class boosted decision tree and train the one of the splits. That'll be the training set. So it is a 2 boosted 2 class. Is that, and then we connect it to a train model as we did in the early experiment, and we connect the data set, and we have to launch the column selector, a name, and we will use credit risk. Yes, and then again we will use another 2 class vector support vector machine. And use it. Okay, we have to have another train model. Here, then connect it to the dataset, and then again do the same. Credit risk. Where's the issue? Oh, this is incorrect. If we run this, define credit risk. Okay. Oh, we would have to normalize the data for that. I missed that step. So we can delete this. Again. To normalize the data. this, we can normalize the data. I did a few errors. Add type, numeric. The first one should be column names. It should be credit risk. Okay. Can use a score model for testing and evaluation. Train model dataset. So you can do for same for the support vector machine. Use the train model and the testing dataset. Yeah, we can score the model. Then we can get an evaluate model and connect both of these score models. Yes. And finally we can run it. Let's start running now. So what it'll do is it'll split the data first, and then it'll run this R script and set the cost adjustment. Then it'll normalize the data for the support vector machine. It'll train the decision tree, and finally it'll score the model. Now it is scored, and now it's gonna evaluate the model. So we can probably visualize this. Can we? Okay. Where isn't this? Okay. Yeah, it looks here. Can go to visualize. Can visualize it? Probably go to credit risk. Visualizations. Okay, let me see. Is it in the evaluation model? Visualize. We can see this code dataset. We can see the comparison of the two different models. One is the support vector machine, and the other one is the decision tree, the two boosted decision tree. So we can see the true positive rate in the first one. I guess that's the decision tree is better. We can look at its code dataset to compare. Yes, the decision tree is better, true positive is correct. So in this case, the decision tree has performed better. And now we can move on to the third step. And I think it shows, we can again go to visualize. So we can see the false negatives, the true positives, the accuracy, the precision, everything can be seen in this visualization. Finally, we move on to the third step to deploy the model. So for this, we will remove the support vector machine, as we know that the decision tree is the one performing better. We will remove what we have done with the support vector machine, as we no longer need it. We just did a test to see how it's going, and we don't need to evaluate the two models. So we will remove the evaluate as well. So we have a scored model now, and now we can convert the training experiment to a predictive experiment by using the web service output. So what this would do is it will output web service. So we seem to have missed a step here, so we have to convert the web service by deleting all the training and all the splitting of data. So we will have it as this, and web service input. Can connect it directly to this. Okay, can remove the split data. This, and then we can directly convert it to. We can remove the training. Convert it directly to this, and yes, so I reverted it back, and now I can delete everything I don't need. Everything from here. Actually, yes, we have this, so we can delete this. This, we can see this model, we can save it as. We'll have to run it again. Yes, and we can save it as. to save it as a trained model. Oh, this one you have to rename it. Trained model for German UCI. Yes, now we can remove all of this and keep score model and German. You can see this train model, and we can remove all the scripting the data. Now we can get a web service input. We can dataset and the train model, and we can get a web service input. Put and connect it directly to this, and a web service output at the end. We can run it. So now we can deploy this as a web service. So the web service is available. Hopefully it's working now. Six. We're just giving some test values. I think not that they're given anything that we can use. No. We're testing it. So we can just give some arbitrary values and see what the prediction is. And 20 columns. Yes, we can see the output, we see the conversion. Yes, we can see that it's working properly now. That's the end of assignment 2 part 2. Thank you.